Hi students, this is Alex here. In this video, we are going to find v where u is given and f of z, which is u plus iv, is an analytic function of z. By using the Milne Thomson method, we are going to get the v. Now as the first part, we are going to find ux, which is a partial derivative with respect to x. So we have to follow quotient rule. So differentiation of the numerator gives 2 into cos 2x into 2, and denominator we have to write as it is. Then minus numerator we have to write as it is, and differentiation of the denominator is e power 2y is a constant because we are doing with respect to x. So two terms will become 0, so we can write directly 0 plus 0, and minus 2 into minus sine 2x into 2 after differentiation. Whole division we have e power 2y plus e power minus 2y minus 2 cos 2x whole square. Now we have to find u of x at z comma 0. So when I substitute x as z, the first term is 4 cos 2z. We multiplied these two 2. Then when y is 0, e power 0 is 1. Similarly here e power 0, that is also 1, minus 2 cos 2z. And here we already have minus 2 sine 2z, and these two minus, it will become plus, and there is a 4. So plus, sorry, it is with the product. So into 4 sine 2z, and whole division, in the denominator, this is 1 plus 1 minus 2 cos 2z whole square. Now this is 2. When I multiply this here, 8 cos 2z. Again this, if I multiply with the next term, minus 8 cos square 2z, then again this is minus 8 sine square 2z whole division, 2 minus 2 cos 2z whole square. By taking minus 8 common from this, we get 8 into cos 2z minus 8 into cos square 2z plus sine square 2z whole division. This is 2 minus 2 cos 2z whole square. Now numerator, the first term is 8 cos 2z minus 8 whole division. We can take 2 common, then this becomes 1 minus cos 2z, and there is a square, so we have to put square for this and square for this, and from the numerator we can take minus 8 common, so this becomes 1 and this becomes minus cos 2z. Then we have denominator also, which is 4, and this becomes 1 minus cos 2z whole square, and we can cancel this entire term with this, and we can also cancel this 4 and 8, so which is minus 2 in the numerator and minus 2, and we left with only 1 minus cos 2z in the denominator. Using the trigonometric formula, this can be written as 2 sine square z. After cancelling this, 1 by sine square z becomes minus cosecant square z. Now we have to find uy. I just copied the u here for reference. Again we have to follow the quotient rule. Derivative of the numerator is 2 cos 2x into 2, and the denominator term is kept as it is. When we do quotient rule differentiation, then minus numerator is x, its derivative will become, sorry, we have to do from the beginning. We are doing with respect to x, sorry, we are doing with respect to y, so this is fully a constant, so its derivative is 0, and into this when we write, anyway the total term is 0, then minus numerator we keep as it is, and derivative of the denominator with respect to y, so e power 2y into 2 plus e power minus 2y into minus 2, and this is in terms of x, so it is 0. Then whole division, we have e power 2y plus e power minus 2y minus 2 cos 2x whole square. Now once again we have to find u_y of z comma 0, and this becomes minus 2 sine 2z, and this is 2 e power 0. E power 0 is 1, so we can leave that, we can just write 2, and this is minus 2 because this is 1 and we have minus 2 whole division, e power 2y plus e power minus 2y minus 2 cos 2x whole square. 2 minus 2 is 0, so totally this is 0. After this we are going to take f of z, which is u+iv, and f dash of z becomes ux plus ivx. From CR equations we have ux equal to vy and uy equal to minus vx, and hence this vx can be replaced from here as minus uy. So totally f dash of z becomes ux minus iuy, and using Milne Thomson method, f of z becomes integral ux of z comma 0 dz minus I integral uy of z comma 0 dz plus c. And the first term is minus cosecant square z. So this is minus cosecant square z with integral dz. Second term is 0 and last term is plus c. This integration is cot z. So f of z becomes cot z plus c. So now we got f of z, and using that we have to find v. So now we are going to take this as u+iv equal to cot of x plus iy, and here we are going to expand this, but before that it is better to change into cos and sine form. So this can be written as cos of x plus iy whole division sine of x plus iy, because cos theta by sin theta is cot theta. Now using cos a plus b formula, cos a plus b is cos a cos b minus sin a sin b. Similarly, sin a plus b is sin a cos b plus cos a sin b. So this becomes cos x cos iy minus sin x sin iy whole division sin x cos iy plus cos x sin iy, and we are going to apply this formula. When you have sin of ix, this becomes I sin hx, and cos of ix, this becomes cos hx. So in the numerator, cos x as it is, cos iy become cos hx minus sin x into sin iy become I sin hx. So I have taken the I here. Whole division, same thing, sin x cos hy. Actually this is y. Even here also it is y, because we are having the terms in terms of y. So cos hy and sin hy, and plus this I will come outside. So I into cos x as it is, sin hy. Now after this, we are going to take the conjugate of this, because we have to split into real part and imaginary part. Conjugate of this, and we are going to multiply with both numerator and denominator. So before that, we have to copy the entire term, cos x cos hy minus I sin x sin hy, whole division, sin x cos hy plus I cos x sin hy into its conjugate of the denominator, sin x into cos hy minus I cos x into sin hy, whole division, again the same thing, sin x into cos hy minus I cos x into sin hy. Now since we need v, I am going to take only the imaginary part, that is taking imaginary part. So for getting imaginary part, this entire term should be multiplied with this I term. Similarly, this entire term should be multiplied with this I term. So cos x cos hy into this, there is a minus I, cos x into sin hy. Again here we have minus I into sin x sin hy into sin x into cos hy, whole division, denominator is common for both real part and imaginary part. This is of the form a plus b, and this is a minus b. So which is a square minus b square. So a square minus b square, we get sin x cos hy whole square minus cos x into sin hy, and there is a I also. Along with that, it is whole square. So now we take minus I common, open bracket, this becomes cos square x and sin hy cos hy plus this becomes sin square x, and we get sin hy cos hy, whole division, this becomes sin x cos hy whole square, I square is minus 1, so we make plus cos x sin hy whole square, cos x sin hy whole square. Then again in the numerator, it is possible to take sin hy cos hy common. So we get cos square x plus sin square x. Then whole division, the denominator we shall take individual square, so sin square x into cos h square y plus cos square x into sin h square y. And now the numerator sin square x plus cos square x, we can make it as 1. So remaining is I into sin hy into cos hy whole division sin square x cos h square y plus cos square x into sin h square y. Now further we can change this sin square as 1 minus cos square. So minus I into sin hy cos hy whole division 1 minus cos square x, and the rest of the terms are written as it is, cos h square y plus cos square x sin h square y. Now let's multiply this with both the term. So numerator is as it is and denominator after multiplication cos h square y minus cos square x into cos h square y plus cos square x into sin h square y. Now this is minus I into sin hy cos hy whole division. Cos hy formula is e power y plus e power minus y by 2, and since there is a whole square we have to put whole square like this. From these two terms we can take minus cos square x common. This becomes cos h square y minus sin h square y, and anyway this is by identity, this value is 1. After that we are going to write the remaining terms. So minus I into sin hy cos hy whole division. This is by expanding using a plus b whole square formula, a square plus 2ab plus b square. Then we have whole division 4, and this is minus cos square x. After that we are going to take LCM. So minus I into sin hy cos hy whole division. Now the LCM is 4. First term is e power y whole square is e power 2y, and second term this becomes 1, so we left with only 2, and this is e power minus 2y. After taking LCM, minus 4 cos square x. Then this 4 will be multiplied with the numerator, so minus I into 4 into sin hy cos hy whole division. We shall take e power terms first together, e power 2y plus e power minus 2y, and we have this 2 and minus 4. From this, if I take 2 common, we have 1 minus 2 cos square x. After taking 2 common, 1 minus 2 cos square x. Now the numerator we split purposely 4 as 2 into 2, so that we can apply the trigonometric formula for this term. That is, this entire term is using sin 2a formula. Sin 2a is 2 sin a cos a. So instead of a we have y. So when it is 2 sin hy cos 2 hy, sorry, when it is 2 sin hy cos hy, it is sin 2 hy. So that's why we split that 4 into 2 into 2. And denominator we shall write these things as it is, plus 2 into, we have another formula, cos 2x, which is 2 cos square x minus 1. But we have just opposite, so this will become minus cos 2x. Because cos 2x is 2 cos square x minus 1. So minus cos 2x is 1 minus 2 cos square x. Now finally, the numerator become minus I into 2. After applying formula, this is sin h 2y, because a is like 2y, a is like y here. So this a is like this y. So it is sin h 2y whole division e power 2y plus e power minus 2y minus 2 cos 2x. So finally v becomes the term with I. So we are going to write I, the term with I directly. So leaving the I, there is a minus sign, and numerator is 2 sin h 2y whole division e power 2y plus e power minus 2y minus 2 cos 2x. So finally we got the v. So the question they have asked, find v, and they have given u, and we got the f of z. From that, taking the real part and the imaginary part, we got the imaginary part v.